Rapid industrialization and growing population are changing the scenario of the world. It is obvious that with all the increment in population and development, the demand for resources will increase. There is also a dramatic increase in the total energy. Resources are limited and demand is unlimited. It seems there is no time for debate. It's time to act. The newest figures from the International Energy Agency predict that by the year 2030, the world will require 60% more energy. But this 60% figure is also a mark of a loss.
I think it's quite amazing that today we still accept that power plants are wasting around 60% of the energy.
How is all that energy going to be produced? And is it at all possible to create enough energy to meet these new demands?
The only sustainable way to reach this target is to integrate the different subsystems of energy. And this means the electrical system and the heat system.
In the European Union, as in the rest of the world, serious issues are being raised regarding the effect of energy production on the environment and the continuity of the energy supply. Fossil fuels such as coal, oil and gas provide 85% of the planet's energy. But supplies are not inexhaustible.
Well, the EU is facing enormous challenges with regard to the energy supply and consumption. Not only the EU has committed itself to reduce greenhouse gas emissions by at least 20, if not 30% by 2020, but also there's genuine strategic concern about the continuity of supply.
The heating and cooling of indoor space takes up approximately 40% of the total energy consumption in the Western world. Finding solutions based on a common infrastructure to increase efficiency in indoor heating and cooling is therefore a prerequisite for stabilizing the world's energy consumption and pollution in the future. But still, a common infrastructure is only known within the electricity supply. The political priority to coordinate the efforts worldwide towards a sustainable energy system is urgently needed. In recent years' energy debate, increased focus has been given to new alternative energy sources which in the future may be able to replace some of the fossils combusted today. The debate rallies around the smart high-tech solutions for the future and tends to forget that renewable energy sources are not likely to replace the majority of the fossils used today. And more importantly, we also tend to forget what is already possible with existing, well-proven and less science fiction-marked technological approaches to energy savings. One of these well-proven technologies for energy efficiency, which is today alarmingly underutilized in almost all Western countries, is district heating and cooling. The fundamental idea of district energy is simple but powerful. Connect multiple heating and cooling energy users through an underground piping network to environmentally responsible energy sources. These are combined heat and power, industrial waste heat and renewable energy sources such as biomass, geothermal and natural sources of heating and cooling.
I'm amazed that district heating and cooling is a very well-hidden secret. People don't know about. That's very simple. We sometimes when me and my friends are discussing this problem, we're talking about is it a low-high technology or a high-low technology? Because it definitely is not the the high technology that everyone is looking for. It's a very low profile technology, very easy to fulfill, but it's have very large benefits.
Most people, they don't know what district energy is. And the reason is that because it's in pipes. It's a pipe system buried in the ground. And also it is well functioning.
We have known this technology for more than 100 years. But it seems that if you have a large problem, you also have a very complex solution. But it's not needed here. If you have these kind of systems, you can solve lots of the energy problems, but looking where have we a resource and where have we a demand and connect it with pipes. That's very simple.
District energy systems produce and pipe steam, hot water or chilled water underground through a dedicated piping network to heat or cool buildings in a given area. District energy reduces energy costs and greenhouse gas emissions while freeing up valuable space in customer buildings by centralizing production equipment. And furthermore, through economies of scale and equipment management, optimizing the use of fuels, power and resources. The beauty of this system is the multi-source advantage of the district energy principle and its ability to make renewable energy more efficient through a large-scale economy.
It's our experience that the most efficient way to use biomass is to use it in large scale. It's much more cheap to use wood chips, wood pellets, also solar collectors and geothermal energy if we can do it in large scale compared with individual solutions. For instance, it's not possible to use geothermal energy as individual solutions due to the huge investments. So therefore, if we want to increase the share of renewable energy in Europe, it's vital that we focus on larger schemes.
District energy is environmentally and economically sound, since it makes it possible to utilize surplus energy, for example from industrial processes, incineration and electrical power production. It is also flexible with regard to energy source, which means that district energy is an ideal principle to combine with renewable energy sources, which often become much more efficient when used on a large scale. Moreover, it also increases safety and reliability in the supply of heat and cooling for consumers, also in the case of an outbreak of an energy supply crisis.
You can change out fuel in the short run. Just within a few hours, you can start up a new boiler unit running on a different kind of fuel. For example, even coal, which is very cheap to store. So both in a very short run, but also in a longer run, the district energy system is superior to other energy supply systems.
The amount of customer value created depends upon how economically and efficiently the district energy provider does this, relative to rival centralized energy sources or customer solutions such as on-site boilers and chiller plants, electrical space heating, individual heat pumps, or building-scale cogeneration facilities. The economic competitiveness of the district energy option is enhanced by the ancillary benefits. These benefits include capital savings from avoided investment in building equipment and reduced labor and maintenance expenses due to simplified operating systems. This means lower costs for water, chemicals, insurance and fuel, and generally higher operating efficiencies due to scale and better load matching. Additionally, in a dense urban environment, there is often a premium value for space that can be reclaimed for other productive uses by displacing mechanical equipment, flues and cooling towers.
There are a lot of benefits, especially if we only put focus on the economical benefits. But what's probably more important is that when we establish huge district energy systems, we can reduce the amount of chimneys from 10,000 to 1 chimney. And that means that we do not have to clean the flue gases at 10,000 chimneys, but we can put focus on how we can treat the flue gases in the most environmental friendly way at only 1 chimney.
The benefits most frequently cited by district energy customers are the convenience, ease of use, and reliability of district energy services. Most district energy systems operate at 4 nines of reliability, which means that the service is available 99.99% of the time on an annual basis. In fact, operational reliability has been a hallmark of the district energy industry. From a customer perspective, there are a number of advantages to connecting a building to district energy service, including ease of use and simplified building operations, avoided capital costs for in-building heating and air conditioning equipment, reduced labor, repair and maintenance expenses. Space is made available for alternative uses and other income activities, highly reliable energy services, and less fuel and chemicals stored and combusted on site.
An interesting fact in the world today is that there are many world leaders using district heating without knowing it. For instance, Barack Obama, Gordon Brown, Medvedev in the Kremlin, the Chinese leaders in Paris and so on. All these major buildings using actually district heating, but without knowing it.
In some ways, the district energy industry is returning to its early roots in adopting combined heat and power, CHP, as the principal source of thermal energy. This trend is particularly strong as commodity fuel costs have escalated dramatically over the last 4 to 5 years, and with that increase in fuel costs, so has the value of recycled heat. In fact, higher fuel costs have stimulated greater interest in investment in energy-efficient infrastructure like CHP with district energy. CHP, sometimes referred to as cogeneration, is the process of recovering the heat or steam produced while making electricity. CHP plants are using that steam in a productive manner, such as for district heating or for steam-based district cooling, rather than just releasing the heat as waste to local lakes, rivers and oceans, as occurs in traditional electricity generating stations.
What's probably the most important when we look at large-scale district energy system is that by that we have the opportunity to utilize low-grade energy sources in society. That means that we can utilize surplus heat from waste incineration plants, from industries. We can use heat from combined heat and power production. We can use heat from large-scale solar collectors. We can use heat from geothermal plants. That means that we can build up an infrastructure, make it possible to utilize energy sources which, without a district energy system, would be lost for the society.
When it comes to the systematic utilization of heat in district heating networks, Denmark is one of the leading countries in the world. The first Danish CHP plant was established in 1903 in the Frederiksberg district of Copenhagen. It started off as a waste incineration plant and 2 months later began using the waste heat from the combustion process to provide heating via a series of tunnels for a nearby orphanage, the local poorhouse and the new hospital. This centralized form of heat supply grew steadily over the years, but it was not until the 1970s, when the energy crisis hit Denmark and the rest of Western Europe, that the district heating sector began to develop at a dramatic rate. A number of initiatives were launched, including the development of effective district heating systems as a means to cutting down on the use of fossil fuels. After the Heat Supply Act was passed in 1979, things really took off. Since then, district heating has increased its total market share from 30 to 60% of homes, or roughly 50% of the total market. And more importantly, the consumption of fossils used to generate 1 megawatt-hour heat for consumers has been brought down from 1.2 megawatt-hour to 0.5.
Well, in Europe, 3/4 of the population live in cities, and almost 70% of all energy demands occur in cities. And this density offers certainly great opportunities. And heating plants allow to have a close look at where are the heat sources in an urban environment and where are the heat sinks, and to make it possible to link these without using extra fuels or extra energy sources. And if the EU speaks about the third industrial revolution when referring to its energy targets, that revolution requires a system change that can only be driven by systematic planning.
As the result of the heat plan, district heating is now the main source of domestic heating and hot water in Denmark. Such a system is essential to achieving sustainability in the heating sector. The expansion of district heating over the past 30 years has made it possible to develop the role of combined heat and power plants. As a result, the Danish authorities have implemented a number of CHP plants that rely solely on low-carbon technology. The seaport of Gdynia in the province of Pomerania is home of one of the largest district heating networks in Poland. Along with the city of Gdansk and the seaside town of Sopot, Gdynia is part of a metropolitan area known as the Tri-City. Up until 1989, district heating was commonplace in Poland, though the infrastructure itself was outdated and suffered from leakage, erosion and significant heat loss. After the fall of communism, many people shunned the idea of district heating, despite it being an efficient source of energy. It was a reminder of darker times of smokestacks coughing thick layers of coal dust.
The Polish district heating sector has undergone quite extensive refurbishment already. Still, we can say in comparison with the most advanced Western European systems, there's still quite some scope for improvement. But the biggest challenge for the Polish energy sector will certainly be to shift from the massive use of coal to using more sustainable fuels. And that's system change, or that fuel shift, will certainly need to be driven mainly by the electricity sector, but district heating and cooling by recovering the waste heat from those plants will certainly continue to be a very important element for optimizing the system.
For over 40 years, the local district heating company, OPEC, has been providing its customers in Gdynia and the surrounding areas with heat. Following a loan from the World Bank in 1994, millions of dollars have been invested in modernizing the original district heating network, substations, and automatic controls. In the so-called old days, OPEC had some serious issues to deal with, like ongoing heat and water losses, unreasonably high level of electricity consumption, summer breaks that caused inconvenience for the customers, environmental pollution due to high emissions, and a great number of damages because of the old infrastructure. The return on the investment for OPEC in this project is not open for discussion. The modernization results related to the World Bank loan are the creation of a district heating system on the European level, improvement of local society living standards, an ecological effect resulted from reduction of toxic gas emissions and improvement of the company's management flow. The benefits from the project for the customers are also remarkable. Perhaps the most important one is the 49% decrease of the heat energy cost. Countries in the EU are ambitious when it comes to utilizing renewable energy sources in the future. They also want to save energy. As things stand today, however, renewable energy sources, though environmentally friendly and pollution-free, cannot provide enough energy on their own to meet the growing demands of the global population.
Why do we not set some minimum efficiency requirements for these plants, taking into account the possibilities of recovering heat? Why do we accept that waste incineration plants are being built somewhere in the greenfield instead of being built or established close to urban areas where heat recovery would be possible? So I think there is, those are the preconditions that policymakers make very clear. We're not going to accept this kind of waste anymore.
The latest directives from the EU Commission are extremely supportive of district heating and cooling. It is recommended as an effectual and progressive energy system, especially regarding new area developments. At this point in time, it is not legislation, only a recommendation, but it is a step in the right direction.
So the big news is that within the new directive, the EU wants to promote renewable energies in different sectors, including the heating and cooling sector. So member states will be required to draw up national plans and to set targets for the different sectors and explain how they're going to reach those targets. And this includes outlining, first of all, give consideration to the need of establishing new district heating networks and or expanding existing district heating and cooling networks and or refurbishing existing district heating and cooling networks.
The Earth needs to be a pleasant place to live, with abundant supplies of energy available and a clean and healthy environment for generations to come. It is efficient and economically viable for local communities. It is also a sound choice for the environment. We need to change the way we think about energy in the future, and the only way to do that is on a global scale. All of us together.